Hello guys, welcome back to a brand new video, and in today's video we're going to start with the last topic of polynomials class 10th. So after this video you have certified in the polynomials chapter and you have officially completed it. Now the relations between zeros and coefficients of the polynomial. It is really simple. Even if you just learn the formula, that will be all. Okay, that will be all. There's no further understanding required. Okay, but I will try from my side to explain each and everything from you. Okay, so let's begin. Now, zeros and coefficients of a polynomial are interrelated as follows. Okay, as follows. Now, suppose here we have alpha is a zero of a polynomial. So, minus b upon a. Now, just wait. I'm just going to give you the formula. Okay, because there are three different kinds of formula here. One is addition formula. Addition formula means alpha plus beta. Now, you might be asking what is alpha and beta. Alpha and beta are the zeros of polynomial. Okay, separate zeros. Okay, whenever the question mentions alpha and beta or xyz number is the zero of the polynomial, you need to put the value alpha plus beta equal to minus b upon a. Now you might be wondering, so what is minus b upon a? Now even if you understand what is minus b upon a, how to implement the values? Now just for example, I have a polynomial x square minus 2x minus 8. Now, let's take a, b and c as the value here. Wait, let me give some more space. So, a value will be 1. Now, just think a is representing the polynomial's coefficient. A, b, c are representing the coefficients. Okay, so b is equal to minus 2. See minus 2 over here. And then c is equal to minus 8. Minus 8. So that's how we are going to implement these values in the equation or in the formula. Okay, and these alpha and beta, they are different from these two. Sorry, the polynomial. Okay. Now, when you start solving questions, you will understand how it works. Okay, right now it might be confusing. Just solve a few questions. You will get the crux of this. Okay. Now the second is alpha into beta or the multiplication formula, that is c upon a, right? Now let's take the same example, 1x square minus 2x minus 8, a is equal to 1, b is equal to minus 2, c is equal to minus 8. Now here we will implement the values of a and c. Okay, so it will be minus 8 only. Okay, since a's value is 1, it will come in denominator. And whatever value they have mentioned in the question for alpha and beta or the zeros of the polynomial, you will put them here. Okay, now let's talk about cubic polynomial. Okay, cubic polynomial, although this portion, this is a small portion and they don't ask many questions on this one, but they might. It is potentially deleted but not sure. They can ask because it is really easy. Okay, they can ask. So just for your general information, just to learn something extra, learn this at least, because this is really simple. The first two formulas are same exact. Okay, suppose there's a cubic polynomial, for example. Let me just give you a standard form: ax cube plus bx square plus cx plus d. Okay, now this is the general form. Now the formula will be alpha plus beta plus gamma. Now you might be wondering, what is gamma now? Same, it is a zero of a polynomial. As the number of the polynomials, as the number of the zeros increases, that's how we're going to increase alpha, beta, gamma, sigma, then some other word that I don't know. Okay, so the formula for this one would be same. minus b upon a, and then you have to just simply implement the values here like this. What's the difference? Now this is the first one. Second is alpha into beta plus beta into gamma plus gamma into alpha. Okay, so here you are adding. So first you are multiplying them, then adding them. It's like that. Once you write the pen down the formulas and learn them, it will be really simple. That's all. Now the formula is same: c upon a, c upon a minus b upon a. No, so there's nothing to learn here. Now only the third formula. Just keep it in mind. Just the third formula: alpha into beta into gamma. Now these two are not equal. Okay, these two are not equal. Here we are directly multiplying alpha, beta, gamma. In the second one, it was alpha into beta plus beta into gamma plus alpha into gamma. It was like that, or gamma into alpha, like that. Here, we're just multiplying them. So the formula will be d upon a. Now, so you might be wondering. Now you might be wondering, what is d? D is this number. Wait, let me do it with the red pen. Here you go. This is d, the last number, the zero coefficient. Sorry, the zero. Okay, sorry. It should be the constant. Sorry. Constant polynomial. Right. Now you are going to take constant polynomial and put in the numerator. And a value, whatever it may be, just implement it. That's your answer. Okay. So let's solve a practice problem. Okay, let's solve a practice problem. So you will get the formulas really easily. Practice problems. Now I'm not writing down the question, so just hear it carefully and look at how my steps are going. Okay. First question: find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Now, there's one thing to keep in mind. When they say verify the relationship between zeros and coefficients, they're actually asking about a relationship between zeros and coefficients of the polynomials that we just learned. That alpha plus beta is equal to minus b upon a. Alpha into beta is equal to c upon a. Right? So let's take an example. First will be 6x square minus 3 minus 7x. Now in the first lecture, I told you something. If you remember, comment it. But if you don't, I'm going to tell you right now. This is not a proper polynomial. This is an improper polynomial because because of this. Sorry, because of this number. This is the placement of the numbers. 6x square minus 7x minus 3. Always remember to follow the flow. Okay, the flow is bigger to smaller. So it will be in decreasing order. Okay, and yes, in the last one, in the last polynomial, there won't be any variable x, y, z, anything. So you can also identify like that also. Now, that would just find the zeros of the polynomial. How are you going to find the zeros of the polynomial? Very easy, by splitting the middle term. So we will multiply these two. 7 6 is 42. 42. Now we have to find the number that will on subtraction or addition give us 3. Okay. Oh, sorry. Even I got confused for a minute. This one, just don't look at this one. Okay. This is in the red zone. Don't look at this one. You're supposed to look at this. Now, if we multiply 6 and 3 minus 3, we get minus 18. Minus 18. So how are we going to find a number that on subtraction, addition, or let's say multiplication, we are going to get 7. So 2 nines is 18. 2 into 9, 18. This could work. Or 6 into 3 is 18. This could also work. And there's another number that is 3 into 6, like that. Or just 18 into 80, 18 into 1. Now, out of these four options, the best option is this one. Okay, because if we subtract 9 from, if we subtract 9 with 2, we'll get 7. Okay, 9 minus 2 is equal to 7. Now, in order to get minus 7, what are we going to do? 6x square minus 9x plus 2x minus 3. Now remember, because these are two alike, because they have a same variable, they can be subtracted. Now, what are we going to get common from these two? Okay, first we need to find the common now. So 3 2s are 6 and 3 is a 9. So let's take 3 common, 3x a common actually, 3x common, then 2x minus 3. That's a common. And in this case, 2x minus 3, actually that's the same number that we're looking for. So let's take plus 1 as common. So 2x minus 3 is a number. So 3x minus, plus 1 and 2x minus 3. We just found a polynomial, zeros of the polynomial. Now, in order to find zeros of the polynomial, just put 3x plus 1 equal to 0 and 2x minus 3 equal to 0. Now, let's shift 1 to the RHS side. So it will be minus 1, so x is equal to minus 1 upon 3. So same, we can do it the same other one, 2x minus 3. So that is going to be x is equal to 3 upon 2. Right. So we found the zeros of the polynomial, or we found, yes, the zero of the polynomial. Now, after finding the zero of the polynomial as minus 1 upon 3 and 3 upon 2, how are we going to verify it? Verification is important, right? So let's take alpha equal to minus 1 upon 3, beta equal to 3 upon 2. That's what we learned earlier. So now, in order to verify this, wait, let me just give it some more space. And now I'm going to draw this one with the red pen, because this is the most important step in these kind of questions. They can ask you for verification, and verification, well, it's the same process, but also you have to maintain the steps. If you write it really stepwise, it is really good. No one can cut your marks in the boards. But if you give it like a really short answer, then the examiner will think, okay, this is really short, I will give only short answers. Okay, only short marks. Suppose 5 marks question, you will only get 2. Right? It's like that. So maintain the steps. Now for verification, alpha equal to minus 1 upon 3, beta equal to 3 upon 2. It's like that. Okay. Now what we learned, that alpha plus beta equal to minus b upon a. Right. Now let's take off polynomial here. 6x square minus 3 minus 7x, and I have written the order wrong again. So minus 7x minus 3, this is the correct order. Now we can implement the values. So alpha is minus 1 upon 3 plus beta is 3 upon 2 equal to minus b. Minus b is minus 7. So minus 7 upon a is 6. Now if we solve them, so in order to get the LCM of 3 and 2 for the LHS side, it is going to be 6. So minus 2 upon 6 plus 3, so it's 9. Okay, and this will be plus 7 upon 6. Now watch this one. Okay, minus 2 plus 9. Will the sign of the 9 change? or the number that we get from subtraction will change to minus? No, because the bigger number is 9 and it has plus sign. So it will be plus 7 upon 6 equal to 7 upon 6. And now you can write LHS equal to RHS. Since in LHS side is alpha plus beta, so whatever 0 that we found, we are going to put the values over there, right? So write this one. Now the next one is alpha into beta. Alpha into beta is equal to C upon A. So minus 1 upon 3 into 3 upon 2 equal to C. What is C? Let's see. Minus 3. Minus 3 upon 6. Now if you remove these two 3's, so minus 1 upon 2 we will get. And if we simplify this, 3 ones are 3, 3 twos are 6, right? And the minus sign remains, so minus 1 upon 2. Now write again LHS equal to RHS. LHS equal to RHS. So now you can finally write hence verified. Just this simple step. Hence verified. That's all. And these kind of questions are asked many times. So make sure to solve as many questions of this chapter as you can. And till then, see you in the next lecture. Tata, bye bye.